Hey guys, welcome back. We're continuing with the course. We're starting with this section called Arithmetic Operations, which is still part of Chapter 1. Now we are very close to the end of the chapter. This will be the fourth section, and conditional statements will be the final section of this chapter. So we'll cover that in another video. We'll hopefully get through all of this in one sitting and not take too long. I apologize if you hear any humming in the background. That is a radiator is sitting pretty close to me. It's a little chilly today, so I have one running to keep me a little bit warm. So hopefully the fan noise won't be too intrusive into the microphone. So the learning objectives for this section are as follows. It says after this section, you'll be able to use variables in various arithmetic operations. You will know how to deal with numbers in user input, and you'll know how to cast values into other fundamental data types. So we learned a little bit about this in the last section, where we were able to cast integers into strings using the string operator in Python. So in this section, we'll learn a little bit more about other types of typecasting from one data type to another. So maybe from floats to strings, strings to floats, et cetera, et cetera. So let's continue. So it says here in the previous sections, you've seen examples with basic arithmetics. In the following table, you can see the most common arithmetic operators in Python with examples. So here are our operators. The plus sign is for addition, and we have 2 plus 4, which shows us the result as 6. The minus sign is for subtraction. Here we have an example, 10 minus 2.5 gives us 7.5. The asterisk or the star is multiplication. Here we have negative 2 times 123 gives us negative 246. The forward slash is for division, and this does floating point results. So if we do 9 divided by 2, we get 4.5. It gives us back numbers with decimals. The double forward slash is division for integer results. Now this is a neat way. So if we do 9 with the double division sign 2, we get back 4. So what this is doing, the double division, is it's rounding down whatever floating point value we get. So 4.5 becomes 4 when you do the double slashes. The percent sign is also called the modulo, and what it does, it returns the remainder whenever you divide two numbers. So in here, the example, we have 9 modulo 2. So what this is doing basically is, let me go down here to the embedded code editor. If we do 9 divided by 2, we know that that equals 4.5. But if we do with rounding down like this, we know that we get back 4. And we know that 4 times 2 is equal to 8. And 8 isn't 9, so our remainder is 1. So that's what this is doing. It's giving back, it's printing back that 1, that remainder. Whatever number is remaining to get us back to the the divisor or the divisor or the dividend? I'm forgetting the terminology here, but that's what's giving back the remainder. So that's what the modulo symbol or operator is for. And then the double asterisk is for exponentiation. So 2 double asterisk 3 is 8. It's the same thing as doing 2 to the third power, or 2 cubed. It's 8. So that's what the double asterisk is. The order of operations is familiar from mathematics. First, calculate the exponents, then multiplication and division, and finally addition and subtraction. The order can be changed with parentheses. So for example, this bit of code, 2 plus 3 times 3 versus print parentheses 2 plus 3 times 3. So what this does is, the first one, it does 3 times 3, which is 9, right? Order of operations, multiplication comes before addition. So 3 times 3 is 9, and then 9 plus 2 is 11. And then the second one, with the parentheses, since whatever operations enclosed in parentheses are supposed to come first, we do 2 plus 3, which is 5, and then we do 5 times 3, which is 15. So that's how we get these two answers. Operands, operators, and data types. A calculation usually consists of operands and operators. So operators are the the function that we want to do. If we want to do addition, subtraction, multiplication, subtraction, and operands are the numbers being operated upon. So the numbers that we use to perform an operation are called the operands. The data type of an operand usually determines the data type of the result. If two integers are added together, the result will also be an integer. If a floating point number is subtracted from another floating point number, the result is a floating point number. In fact, if a single one of the operands in an expression is a floating point number, the result will also be a floating point number, regardless of the other operands. Division is an exception, as we saw earlier up here. We got back a floating point number instead of a whole number. Its result is a floating point number even if the operands are integers. For example, 1 divided by 5 will result in the floating point number 0.2. Another example, our height is 172.5, our weight is 68.55. So we're calculating the BMI, or the body mass index, which is calculated by dividing body mass with the square of the height. So here we do BMI is equal to weight divided by height divided by 100 squared. And then we print the BMI. This program prints out the following. The BMI is 23.0, blah, 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 blah. Notice Python also has an integer division operator. If the operands are integers, it will produce an integer. The result is rounded down to the nearest integer. For example, this program. So we have the variable x, which is assigned the value of 3, and the variable y, which is assigned the value of 2. If we print the division operator, 3 divided by 2, we get 1.5. If we print the division integer, so x double division y, we get back 1 because it rounds down to the nearest integer. Numbers as input. We have already used the input command to read in strings from the user. The same function can be used to read in numbers, but the string produced by the function must then be converted to a numeric data type in the program code. In the previous section, we cast integers as strings with the str function, the string command, which I talked a little bit about at the beginning of the video. The same basic principle applies here, but the name of the casting function will be different. A string can be converted into an integer with the function int. The following program asks the user for the year of birth and stores it in the variable input string. The program then creates another variable called year, which contains the year converted into an integer. And then after this, the calculation 2021 minus year is possible using the user supplied value. So this is our code here. It says the variable input string takes in a string value. Then we have a variable called year, which typecasts that string value into an integer. And then we print out your age at the end of the year, and then we do the operation here. So we do 2021 minus the year. So if we say which year you were born, we provide the value 1995. It says your age at the end of the year of 2021 will be 26. Usually you do not need to create two separate variables like input string and year above to read a number value from the user. Instead, reading the input with the input function and converting it into the integer function can be achieved in one go. So here we have year is equal to, and then we're typecasting whatever value that we get here directly into an integer. And that way we can skip having to create another variable that does the typecasting, and then we can do the operation in our print statement. Similarly, a string can be converted into a floating point number with the function float. This program asks the user for their height and weight and uses these to calculate their BMI. So we first ask for the height, which we save it as we typecast the user inputted value into a float. Same thing with the weight, and then we can calculate. We can do some mathematics to find the BMI. So here it says, what is your height? 163 centimeters. What is your weight? 74.45 kilograms. And then it prints back the BMI. All right, so we have our first exercise called times 5. It says, please write a program which asks the user for a number. The program then prints out the number multiplied by 5. The program should function as follows. So please type in a number. You provide 3, then we say 3 times 5 is 15. So we can say number is equal to integer input. Please type in a number, space. Then we can do print, use f strings, and say number times 5 is, pardon me, times 5 is, then we do number times 5, like that. Whoops. So if we run this, we should be asked, please type in a number. If we're writing 3, so 3 times 1. Oh, I'm sorry, I used the wrong operator. 3, and we get 15. If we do a different number, 5 times 5 is, I'm sorry, that didn't work. It's 25. If we do 6, we should get back 30. So we should be okay here. So if we run our test, and it's good sometimes to do it yourself just to provide different values and see how your program reacts to be certain that it will pass all the tests, but you'll never know if it passes the tests if you don't run the test. And we can also view the model solution. So here I have number, input, please type in a number, then result is typecasted, and then just prints the result, which is a pretty neat way of doing it. And so instead of doing the operation in here, we can just add this step, which does the typecasting and the operation, and then we print it out over here. But this is my answer. You can go with this one, or you can go with the model solution if you prefer. They both do the exact same thing. Name and age. Please write a program. So this is another exercise called name and age, which instructs us to please write a program which asks the user for their name and year of birth. The program then prints out a message as follows. What is your name? Francis Fictitious. Which year were you born? 1990. Then it prints, hi, Francis Fictitious. You will be 31 years old at the end of the year 2021. So here we say name is equal to input. What is your name? Then we have year, and we say input, which year were you born? And then we print, hi, name, you will be, which I'm assuming will be 2021 minus years old at the end of the year 2021. I think that should be the way to do it. So let's run and see if we get any errors. So we just say Stefan, we'll say 1997. Hi, Stefan. You'll be 24 years old at the end of the year 2021. So something here is wrong. Okay, there we go. So that extra space here was not good for us. So yeah, so that's how I decided to do it. So if we do our test here and see if we pass, we passed, and we can again view the model solution to compare. So here it says name, what is your name? And it's just, we're not needing to typecast anything here, we're just accepting a string input from the users. And then here, they did the same thing that we did. They called their variable born, we called it year, and so and then they typecasted the string input into an integer. So which year were you born? We turn that into an integer. And then they calculated age as a separate variable. So age 2021 minus born. And then they printed out, hi, name, you'll be blah, 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 2021. So this is our solution. Very short, very concise. They added an extra step here that does a separate calculation, which is a good thing to do just to be safe. But if you just want to one-line it, this is also another way you can do it. So you can do here is just age is equal to, and then do 2021 minus year, and then you can go in here and print age like that. So when we run it, so if I say Stefan, say 1997, it says 24 at the end of 2021. Again, if we test, we should pass as well. So these are the two ways that you could have done this exercise. So let's keep going. Using variables. Let's have a look at a program which calculates the sum of three numbers given by the user. So number one, we ask for the input and we typecast it to an integer. Do the same thing for number two and the variables number two and number three. And then we calculate the sum as number one plus number two plus number three, and then we print the sum. So an example of the execution of the program. So first number we provide 5, second number we provide 21, third number we provide 7, and so the sum of the numbers becomes 33. The program uses 4 different variables, but 2 would easily suffice in this case. So sum is equal to 0, number is equal to int input first number, then sum is equal to sum plus number. Then we do number is equal to integer second number, then we do sum is equal to sum plus number. So as you can see, we're just reusing the same number variable and overriding it over and over, and then we're just, again, adding on what we currently have to what we're getting from the input of the user. And then we print out the sum. So now all inputs from the user are read into the one and the same variable number. The value of the variable sum is increased by the value of the variable number, which each time the user inputs a new number. Let's take a closer look at this command. Sum is equal to sum plus number. Here, the value of the variable sum and the value of the variable number are added together, and the result is stored back in the variable sum. For example, if before the command the value of sum is 3 and the value of number is 2, after the command is executed, the value of sum is 5. Increasing the value of a variable is a very common operation. As such, there is commonly used shorthand notation which achieves the same result as the explicit summing up above. So instead of doing sum is equal to sum plus number, we can just do sum plus equals numbers. So these two do the exact same thing. If you're hard on self-documenting code and writing clear code, then this will be better. But if you are okay writing a short program, and this is very common knowledge for most programmers using shorthand notation like this, plus equals, this also works. There's also a minus equals, a multiplication equals, division equals. They do the same thing, but for subtraction, for multiplication, and for division. So this allows us to write the above program a little more concisely. So sum is equal to 0. The number is equal to the typecasted input into an integer. So we do sum plus equals number 3 times, and then we print out the sum. In fact, we don't necessarily need the variable number at all. The inputs from the user can also be processed like this. So we can really condense the verbose nature of our code by doing this. So sum is equal to 0. Then we do sum plus equals the typecasted input into an integer. We do that 3 times, and then we print out the sum. Of course, it will depend on the context how many variables are needed. If it is required to remember each value the user inputs, it will not be possible to reuse the same variable to read different values from the user. So consider the following. Number 1, integer, which again, same thing, we typecast the input into an integer. We do it twice for number 1, number 2. Then we print out number 1 plus number 2 is equal to number 1 plus number 2. So first number 2, second number 3, 2 plus 3 is equal to 5. On the other hand, the above program does not have a named variable for storing the sum of the two values. Reusing a variable only makes sense when there is a need to temporarily store things of a similar type and purpose. For example, when summing numbers. In the following example, the variable data is used to first store the name of the user and then their age. This is not at all sensible. Because if we need to come back and recall the name, we won't be able to, because now data is pointing to the age instead of the name. So a better idea is to use separate variables with descriptive names. So the variable name will store our name, which we can print out if we need it, and the variable age tracks our age, and then we can recall them whenever we want in the future. So if we want to print hi, name, your age is blah, 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 as one whole sentence, we can do that because we're tracking our name and age as 2 separate variables. So here we have another exercise called seconds in a day. It says, please write a program which asks the user for a number of days. The program then prints out the number of seconds in the amount of days given. The program should function as follows. How many days? 1. Seconds in that many days? 86,400. Another example, how many days? 7. Seconds in that many days? 604,800. Okay, so here we have a variable called number of days, which is going, we're going to cast it here, our input value into an integer, say how many days, and then we could have um, a variable equal number of seconds in which we do the operation. So that would be number of days times 60 times 24, if I'm not mistaken. I think that's how, I think it would be times 60, 60, 24. But let's just go with this for a second. We'll test it out and then make any adjustments. Then here we'll do a print f strings. We'll say seconds in that many days. And then we'll do number of seconds, like that. So let's run it and see what it does. So we provide 1. Okay, so I think it should be 60, 60. Like this. Yes, 86,400. So that's, I think that should be good. So if we do test, let's see how we do. And we passed. So if you view the model solution, let me close these other 2 tabs. So how many? So they have a variable here called how many, and it takes in how many days. So they don't typecast in line as we did, but they do it here with the second variable called days, and then they typecast how many into an integer. And in seconds, they do days times 24 times 60 times 60, and then they print it out. So we did something very similar, but we just skipped this step. We just did this in line with this. Show you in a second here. So here, number of days, we typecast the inputted value into an integer. Then we do number of seconds, and then we recall that variable times 60 times 60 times 24, and then we print out that final answer. So again, if we run, if we do 7, we get 604,800. And again, if we test, we should pass our test, which is awesome. All right, let's continue. We have another, oh wow. So we got exercises for the rest of the section. So let's get through these. So this exercise is called Fix the Code. Fix the code product. This program asks the user for 3 numbers. The program then prints out their product. That is, the numbers multiplied by each other. There is, however, something wrong with the program. It doesn't work quite right. As you can see if you run it, please fix it. An example of the expected execution of the program. And I love that they do this, so we can have this in our head and we can have this to read as we're reworking the code to make sure that we are getting the expected outputs. Always run your code when you're writing along to see how you're progressing. Okay, so we say it should ask us first, please type in the first number. So if we provide 2, and then we ask us again the second number, 3, and then please type in the third number, 5, the product is 30. So here we have a number, please type in the first number, please type in the second number, please type in the third number. And we do product is equal to number times number times number. So if we run this, let's see what happens. 2, 3, 5. The product is 125. That's unique how we got there. But we can fix this by, so I think it's doing 5 times 5 times 5. Right, instead of doing 2 times 2 times 5. So we can fix this by just changing the variables like that. So this is a pretty quick fix. If we run it, do 2, 3, 5, we get 30. And if we run our test, we should pass. Awesome. So another way we can do this, as I'm thinking, we can do, let me comment this out. So we can do number is equal to integer input. Please type in the first number. And then we can do product is equal to u times equal, actually no, we do product is equal to 1, and then actually declare product first, and then here we do product times equals number, and then basically just repeat this. And then do it one more time. And then we can print down here the product is product. I think this will work. Let's see. So if we do 2, 3, 5, yep, it works. So you can do it this way if you'd like. I think it's a little bit, a little less cleaner, a little bit harder to follow along, but it works. So you can do it this way, or you could do it this way. I'm gonna uncomment this out and comment this out. And at the end of the chapter, what I'm gonna do is I'm gonna upload all of these solutions to my GitHub, so you can just go over there and rework them. But again, if we test our original code, we should pass. And if we choose view the model solution, they did the exact same thing we did. Just change the variables from number to number 1, number 2, number 3. Then products is equal to number 1 times number 2 times number 3, and then we just print it back out. So that was pretty straightforward. All right, another exercise called sum and product. Please write a program which asks the user for 2 numbers. The program will then print out the sum and the product of the 2 numbers. The program should function as follows. Number 1, and we provide 3. Number 2, we provide 7. The sum of the 2 numbers is 10, and the product of the numbers is 21. So, if I'm not mistaken, okay, let's just do it the easier first. So we have number 1 is equal to int input number 1, and then we have number 2. Sum is equal to number 1 number 1 plus number 2, and product is equal to number 1 times number 2. And then we just print with an F string here. So the sum of the numbers, we do sum, and the product, and we print out the product. I'm sorry. All right, so if we run this, first number is 3, second number is 7, we get 10 and 21. So if we do our test here, this should also pass. And we can view the model solution. So do the same thing we did, typecast, but they just did it in line here instead of saving them to do 2 different variables, which is again another neater way to do this. But if you want to know exactly what's been going on without having to do it in line, you can do it this way. But I like how they did it in line, so you can do that, and you can do this, and then you can get rid of this section. And then when we click run, so if we do 3 and 7, we still get the same answers. And if we run our tests, it still works. Awesome. This exercise is called sum and mean. It says, please write a program which asks the user for 4 numbers. The program then prints out the sum and the mean of the numbers. The program should function as follows. So we ask for number 1, we provide 2, number 2, provide 1, number 3, provide 6, number 4, we provide 7. The sum of the numbers is 16, and the mean is 4.0. The mean, which is I think the average, which is just all 4 numbers added up together divided by the amount of numbers that we have. So we add 2 plus 1 plus 6 plus 7, which is what, 3, 10, 16, and then 16 divided by 4 is 4.0. All right, so number 1 is equal to int input number 1. Then we just duplicate this, number 2, 3, 4, do the same thing here, 4, 3, 2, and then we can do print the sum of the numbers is do number 1 plus number 2 plus number 3 plus number 4. So we'll just run this for now, see how it does. So it says syntax on line -1, invalid syntax. Invalid syntax. Number 1, number 2, number 3, number 4. Invalid syntax. Print. Did I write the printf wrong? No, I don't think so. Let me get rid of this for a second, see what it does. Okay, so there is a problem here. Two, 1, 6, 7. The sum of the numbers is 3, so something's right. So it's adding 2 and 1. Okay, so I don't know what was causing that error. Let's see if it behaves itself here. 2, 1, 6, 7. We get 9, and then again if we do plus number 4, see what happens. We get that error? No, we don't. So I don't know what was causing that error. Right, we get 16. So what I'm gonna do here is just copy this. Create a variable here called sum, and a variable here called mean, and we do sum divided by 4. So we do sum, and the mean is mean. So now if we do 2, 1, 6, and 7, we get the sum of the numbers is 16 and the mean is 4.0. All right, I think that's a good solution. And again, you can do this. So instead of having a separate variable for mean, you can do it in line like that. So again, we do 2, 1, 6, 7, it still works. And you can also just do this inline here, but because the code editor is so small, the embedded one is so thin, I'm just gonna leave it as 2 separate variables because it's a little bit easier to read instead of having to scroll off screen to see what the rest of the code looks like. If we run our tests, we should be kosher. Let me close this, and we are. We can check the model solution. And yeah, same thing we did. Instead of just, with the exception of having the variable for mean, they just did it in line here. But yeah, have 4 variables for number 1, 2, 3, and 4. Cast those that input values into integers. Find the sum, and then use that sum to find the mean. All right, we have 2 more exercises to go. So let's keep going. Oh, we're almost done. This one's called food expenditure. Please write a program which estimates a user's typical food expenditure. The program asks the user how many times a week they eat at the student cafeteria. Then it asks for the price of a typical student lunch and for money spent on groceries during the week. Based on this information, the program calculates the user's typical food expenditure both weekly and daily. The program should function as follows. How many times a week do you eat at the student cafeteria? 4 times. The price of a typical student lunch? 2.5. How much money do you spend on groceries in a week? 28.5. And then average food expenditure daily is 4.5 euros and 38.5 euros for weekly. Okay, so this might be a little tricky. So we need a variable to track how many times we go to the student cafeteria. So this is an integer input. Say how many times a week do you eat at the student cafeteria? Then we have lunch price. This should be a float. Input the price of a typical student lunch. And then weekly groceries. How much money do you spend? Oops. Do you spend on groceries in a wow in a week? So what I'm going to do first is I'm just going to print out the values that we have. So cafeteria visits, and then we do cafeteria visits. Then we do lunch price. Oh, what just happened? It took me back for whatever reason. Sorry about that. Now we have to, okay, we don't have to start over. So here we have lunch price. And then we have weekly groceries. So if we run this, it says how many times do you eat at the student cafeteria? We said 4 times a week. With a typical lunch, we say 2.5. And we do 28.5. So cafeteria visits 4, 2.5, and 28.5. So average food expenditure. So how do they get 5.5? Is this 28.5 divided by 7? Right? It's 28.5 divided by 7, which is 8. Pardon me, it's 4.0. So 4.0 plus 2.5. Yeah, this is the one though. Let me figure out how they did this math. Okay, I think I have it figured out. If you do the number of cafeteria visits times the lunch price plus the weekly groceries divided by 7, that should give you the daily expenditure. And then if you do the lunch price times the cafeteria visits plus the weekly groceries, it gives you the weekly expenditures. So yeah, the formula was a little kind of annoying to figure it out, but we figured it out. I had to take a second to really think about it because when you're just reading it through and then trying to do it, it's kind of tricky. But I didn't format it correctly yet, but I just was going back and forth and just printing it back out. So we're reading back the cafeteria visits, the lunch price, and the weekly groceries, and then we print what the daily and what the weekly is. So we just have to reformat these and say daily 5.5 euros and weekly, which is 38.5 euros. I'll just hide those comments for now. So if we click run, it says, ask us how many times do we eat at the cafeteria. We say 4 times a week. How many times is a typical student lunch? We say 2.5. And the weekly groceries is 28.5. And here our daily is 5.5 euros and weekly is 3.5 euros. And if we test, I think we should be kosher. So let's view the model solution. This one I was kind of waiting for. So times in cafeteria, which is what we did. Prices of lunch, which is what we did. And then groceries. So these two are floats, which is also what we did. So the weekly is equal to groceries plus times in cafeteria times price of lunch. Oh, that's even a simpler way to think about it. And then average food expenditure. So we have printing the daily and printing the weekly. I didn't even print the average food expenditure, so I need to do that here. Okay. Cool. So I'm just gonna remove this. This was just for my own sanity. But this is basically the answers. And I like the way they did it. They first calculated the weekly, and then used that to calculate the daily. I think that's a little bit easier to read, so we'll do the same thing. Which is this. Lunch prices times cafeteria visits plus weekly groceries. And then we can use that to calculate. So here we do weekly divided by 7. And then here we just do weekly. And if we run, we do 4, 2.5, 28.5. Oh, pardon me, I spelled this completely wrong. 4, 2.5, 28.5. And yeah, there we go, we got the same answers. So that's the answer to this one. Again, kind of a pain in the butt, but we got there at the end. Now we have the final exercise here, which I'm going to do in a separate video because this one's been going on for about 40 minutes. So the next one will be a very short video, but it will be covering this exercise. So stay tuned for that, please.